This video is about chain rule of derivatives. If y equals g of u, where u equals f of x, then this is the formula for chain rule. You could say I put these two pictures. When you do the chain rule for derivatives, think about how to peel the onion. You always from outside, then go to inside when you peel the onion. Chain rule is the same way to figure out the derivative of a little bit complicated function. Let's talk about number 1. Find the gradient function dy by dx. We know the y equals 2x plus 7 over 5. And you will think this is so complicated. I only learned power rule, so how to figure this out? Let u equals 2x plus 7. So you can rewrite your function y equals u to the 5th power. Then I can do the derivative to y equals u to the 5th power. We already learned the power rule. So we get the dy by du this time because u is the independent variable equals drop down minus 1 so that you will get the 5 times u to the 4th power. Then look at this one. U equals 2x plus 7. For this function, when we do the derivative, you will get the du by dx because x is the independent variable for this function. That is 2 because derivative for 2x will be 2. The derivative for 7 will be 0. This derivative notation was given by Gottfried Leibniz, who is a great German scientist. Isaac Newton and Gottfried Leibniz are the co-founder for calculus. For dy by dx, basically it comes from the limit of different quotient, like this. This limit of different quotient implies dy by dx is a quotient. Therefore, we can write down dy by dx equals dy by du times du by dx. Dy by du is here, 5u to the 4th power. Then times du by dx, it's here, you got 2. So I organize 5 times 2 is 10. Since my independent variable is x, so I change this u into 2x plus 7. 2x plus 7 to the 4th power. Then this will be the derivative for the problem. Then the dy by dx equals dy by du times du by dx. We call this is a chain rule of derivative. But when you do the derivative of the function, like 2x plus 7 to the fifth power. If you use u equals g of x, then it will take you a long time to finish one problem. That's the reason when you use a chain rule, I need you to think about how to peel onions. You always from outside. So when you do the derivative of a function by chain rule, think about you always do the derivative of outside function first. In your mind, when you work out the derivative of 2x plus 7 to the fifth power, you think the outside function is a power function, something to the fifth power. So use power rule. You drop down the 5. Inside don't change. So you get the 2x plus 7 to the fourth power because the 5 minus 1. Then you do the derivative to 2x plus 7. That's 2. Then you organize, you will get the 10 times 2x plus 7 to the fourth power. For number 2, still, I need you to think about the outside function, that is the fourth power. When you use the power rule, the coefficient stays, so 6 times. Drop down the power is 4. Then inside don't change, negative x third power plus 2x minus 5. This 4 minus 1 is third power. Then you will work on the derivative inside. Negative x third power plus 2x minus 5. When you do the derivative, you will get the negative 3x squared plus 2. Because constant number will be 0, so I will write down here negative 3x squared plus 2. Then I organize 24 negative x third power plus 2x minus 5 third power times negative 3x squared plus 2. Just leave as it is. You don't have to do the distributive property to expand this polynomial function. Now let's go to 3. First step, change this into single power form. Then for dy by dx, you will do the power rule first. Think about something to the negative third power. So we will use power rule. 3 is a coefficient. Drop down negative 3. You will get the 5x minus 4 to the negative fourth power. After this, you will do the derivative to inside. That's 5x minus 4. Derivative will be 5. Then you can organize. 3 times negative 3 times 5 will be negative 45. Then 5x minus 4 to the negative fourth power. Then you change negative exponents to the positive. Move 5x minus 4 to the denominator. That is 5x minus 4 to the fourth power. This will be the dy by dx. Now let's go to number 4. We need to change this into the single power. So we get the 1 over third power. Then for the derivative, you will do the power rule first, because that's the outside function. drop down the exponents. Then you minus 1. Inside don't change. 1/3 minus 1, you will get, this is 3 over 3. So you will get a negative 2 over 3. Negative 2 over 3. Then you will do the derivative to the inside function. Let me write down here, 4x to the third power minus 3x squared minus 9. Do the derivative, you will get 12x squared minus 6x. Constant number will be 0. So you will get the 12x squared minus 6x. Then you organize. Denominator, I have 3. This is a negative exponents, definitely go to denominator. So cubic root of 4x third power minus 3x squared minus 9 squared. Then to the top, you will get 12x squared minus 6x. This will be the derivative of number 4. Now let's go to number 5. When you see square root of x pattern, you will get the 1/2 square root of x. When you see 1 over square root of x, just remember you will get negative 1 2x square root of x. Therefore, for number 5, you can think about this is the 7 times 1 over square root 3 minus x squared. So dy by dx equals, coefficient is 7. This one you think about this using this rule. For x, you will change into 3 minus x squared. So you will get the negative 1. 2 times 3 minus x squared. Then square root 3 minus x squared. Then do the derivative inside 3 minus x squared. You will get the 0 minus 2x. So basically multiply by negative 2x. Then we organize. 2 reduce. Negative will change into positive. So to the top we have 7x. Denominator, you will get 3 minus x squared. Square root 3 minus x squared. That's dy by dx. For number 6, we will use power rule first. 3 is coefficient. Drop down the exponents, that's 2. So inside don't change. To the first power. Then you will do the derivative to x minus 3 over x to the third power. We change this one into x minus 3 times x to the negative third power. So you will get derivative for x is 1 minus 3 times negative 3. Drop down minus 1, here's negative 4. Therefore, you will get the 1 plus 9 over x to the fourth power. So we will write down 1 plus 9 over x to the fourth power. This is a dy by dx. It equals 6 times x minus 3x to the third power times 1 plus 9 over x to the fourth power. Please do not forget this dy by dx. So I rewrite dy by dx equals this. You don't have to expand. Just leave as it is.